Good morning, dear students. Last class I told definitions of different types of sets, and before that, in first class, I have given definition of set also. In that set, which statement is forming set, which statement is does not forming set. About these two also I told. And after completion of that, I have given definitions of different types of sets. That is null sets. That is null set means empty sets, finite sets, infinite sets, singleton sets, equal sets. Like that, I have given definitions of different types of sets. Today also, I'll give definitions of some different types of sets here. First one is subsets. What is meant by subset here first? Subsets. Intervals as subsets of real numbers, universal sets and power sets. Like that today we'll discuss about all these four sets, and after completion of this we'll solve the problems on exercise of 1.1 of first piece textbook. Next one is here. First one is subset. What is meant by subset first? Subset here. Subsets. What we can give the actual definition of a subset here? Let capital A and capital B. Let capital A and capital B be two sets. Be two sets such that if every element of A every element of the sets capital A is the element of the set capital B, then the sets capital A is called the subset of the sets of the set capital B. Here I am taking two sets. In that two sets, first I am going to selecting first set capital A. Then you must compare every element of A is the element of B or not. That's why according to definition here, let capital A and capital B be two sets such that if every element of the set A is the element of the set B, then the set A is called the subset of the set capital B. ಇಲ್ಲಿ ಎ ಅಂಡ್ ಬಿ ಅಂತ ಎರಡು ಸೆಟ್ಸ್ ತಗೊಂತಾ ಇದೀವಿ. ಕಂಪೇರ್ ಮಾಡ್ಕೋಬೇಕು ಹೇಗಂದ್ರೆ ಸೆಟ್ ಎ ಇರುವಂತಹ ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟ್ ಸೆಟ್ ಬಿ ಇರಬೇಕು. But in case of equal sets, same concept I have given last class in case of equal sets also. If every element of set A is the element of set B and every element of the set B is the element. This is the definition of subsets. In case of two sets A and B, if every element of set A is the element of set B, if every element of the set A is the element of set B, then we are calling capital A is the subset of the set capital B here. For example, examples easily we can analyze which is subset which is not subset. Here every element of set A is the every element of the set B, then we are calling capital A is the subset of the set capital B, but B is called a supersets of the set A here, and is denoted by, and it is denoted by, and it is denoted by A is subset B here. A is subset B. A is subset B means A is contained in B. A is contained in B means ಅಂದ್ರೆ A ಇರುವಂತಹ ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟ್ಸ್ ಆಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಸೆಟ್ B ಅಲ್ಲಿ ಇದಾವ ಅಂತ ಅರ್ಥ. That's why we are calling here A is contained B. That's it is symbolically it is represented by like this A is subset B here. ಎರಡು ಸೆಟ್ಸ್ ಎ ಆ್ಯಂಡ್ ಬಿ ಎರಡು ಸೆಟ್ಸ್ ತಗೊಳಿದ್ರೆ ಎ ಇರುವಂಥ ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟು ಸೆಟ್ ಬಿ ಅಲ್ಲಿ ಇರಬೇಕು, ಇದ್ರೆ ಅವಾಗ ಏನು ನಾವು ಬಿಗೆ ಸಬ್ಸೆಟ್ ಆಗುತ್ತೆ ಅಂತೀವಿ. ಆದರೆ ರಿವರ್ಸ್ ಬಂದರೆ ಬಿ ಎಗೆ ಸೂಪರ್ ಸೆಟ್ ಆಗುತ್ತೆ. ಸೂಪರ್ ಸೆಟ್ ಆದರೆ ದಟ್ ಈಸ್ ಎ ಇಸ್ ಕಂಟೈನ್ಡ್ ಇನ್ ಬಿ. ಎ ಇಸ್ ಕಂಟೈನ್ಡ್ ಇನ್ ಬಿ ಆಗ್ತಾ ಇದ್ರೆ ಎಗೆ ಸಂಬಂಧಪಟ್ಟಿದ್ದು ಸೆಟ್ ಎಗೆ ಸಂಬಂಧಪಟ್ಟಿದ್ದು ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ಸೆಟ್ ಬಿ ಯಲ್ಲಿದ್ದಾವೆ ಅಂತ ಅರ್ಥ. It is the definition of subsets. That is representation of subset is A is contained B. But to some examples easily we can show and which is subset and which is not subset here. See here, for example, examples for subsets. Examples for subset here. That A is equal to 1, 2, 3 here, and B is equal to here, and set B is equal to, take some elements here, 1, 2, 3, 4, 5, 6, 7, 8 something here. See here, if you can observe, set A is subset to B or not, we have to check about these two here. Set A is the set A having the elements now 1, 2, 3. Set B have the elements from 1, 2, 3, 4, 5, 6, 7, 8 here. You can observe every element of set A is the element of set B. Check them. Here 1 is there. In set A 1 is there. Same element in set B 1 also is there. In set A 2 is there. Same element in 2 also is there. 3 and 3 whether is it present or not here in set B. That's why easily we can tell A is subset of B. Therefore A is subset to B we can write. Or we can write in words A is subset. A is the subset of B. Subset of the set B. Of the set B here. Or A is contained in B. Or A is contained in B. We can call it is by A is contained in B, or symbolically you can write like this also. That is A is contained B. Or we can write in the words A is a subset of the set capital B. Like that we are showing subsets. Simply, if every element of the set A is the element of the set B or not, we have to check about these two. Then easily we can tell then A is the subset of B. And which is not the subset. And we must check that also. By solving this, easily we can analyze which is subset and which is not subset. That's why one more example I'll give you in the case of which is not subset here. First example this, second example. A is equal to 9, 2, 5 something is there. Here also. And B is equal to, here you can take some elements 1, 2, 3, 4, 5 lines. See here. Every element of set A is the every element of set A is the element of the set B, then only we are calling A is the subset of the set capital B here. 9 is there. 9 is there, but here 9 does not belongs to set B. Enough, one element is enough. One element is not present set B, which is belongs to capital A and which is does not belongs to capital B, then easily we can tell A is not subset of the set capital B. ಡೆಫಿನೇಷನ್ ಪ್ರಕಾರ ನಮಗೆ ಸೆಟ್ ಏಲಿರುವಂಥ ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟು ಸೆಟ್ ಬಿಲಿ ಇರಬೇಕು. ಒಂದು ಎಲಿಮೆಂಟ್ ಸಾಕು, ಒಂದಿಲ್ಲ ಅಂದರೆ ಸಾಕು, ಡೈರೆಕ್ಟ್ ನಾವು ಹೇಳ್ಬಹುದು ಇದು ಸಬ್ಸೆಟ್ ಆಗಲ್ಲ ಅಂತ. ಇಲ್ಲಿ ನೋಡಿ, ಈ ಎರಡನೇ ಎಕ್ಸಾಂಪಲಲ್ಲಿ, ಸೆಕೆಂಡ್ ಎಕ್ಸಾಂಪಲಲ್ಲಿ 9 ಸೆಟ್ ಏಲಿದೆ, ಬಟ್ ಸೆಟ್ ಬಿ ಅಲ್ಲಿ ಇಲ್ಲ. ಡೈರೆಕ್ಟ್ಲಿ ವಿ ಕ್ಯಾನ್ ಟೆಲ್ ಎ ಇಸ್ ನಾಟ್ ಸಬ್ಸೆಟ್ ಆಫ್ ಬಿ. ಸರ್ ಮೇನ್ ಟು ಎಲಿಮೆಂಟ್ಸ್ ನಾವೆಲ್ಲ ಹೆಂಗಾಗಲ್ಲ ಅಂತ ಡೌಟ್ ಬರ್ಬೋದು ನಿಮಗೆ. ಬಟ್ ಡೆಫಿನೇಷನ್ ಪ್ರಕಾರ, in case of definition, every element of set A, every is there na, every is very important in case of subsets and equal sets. That's why every word is there, no, very important here. Every element of the set A is the element of the set B, then we are calling capital A is the subset of the set capital B. According to that definition, one element is present in set A, but one element is not present in set B. That definition does not applicable for these two sets. That's why we can tell A is not subset of the set capital B. For A is not, A does not contain set B like this. Or we can type in words, A is not subset. A is not subset. A is not subset of the sets. A is not subset of the set B here. A is not subset of the set B here, because reason for this, because X 9 belongs to capital A. 9 present in set, but 9 does not belong to capital set capital B. 9 present is there in set A, but 9 does not present in the set B. Therefore, easily we can tell 9 A is not subset of the set capital B. Like that, we are representing subset. If every element of first set is the every element of second set, definitely the first set is the subset of the set second sets. If any one element does not present means one element is there. Say for example 9 is there here. I have taken an example 9 here. 9 element is there. One element 9 present in set A, but does not present in set B. In this case, that first set is not a subset of the second set. That's why A is does not contain set B. A does not contain in set B. That's why A is not subset of the set capital B. Like that, through the examples we are showing subsets. At the same time, under the subset we are seeing some important points. About those points now we'll discuss. Note under the subset, note here. Under this note under the subsets here, some important points are there under the note of subsets here. Up to that, I have given definition of subset and have given examples also for the subsets, and in which case it is a subset and which case does not form subsets. Now, just we are discussing about some important points under the note here. Note means here, first point is every set every set is subset to itself, subset to itself. That is represented by, that is represented by A is subset or equal to A here. Like A, you can consider cap A. A is subset equal to A. Or you can consider set B. B is subset to A. How means every set is subset by itself or not? By checking, I will give an example here. A is equal to some elements you can take 1, 2, 3. Because every element of set is the element of set A. You can take one more element, equal sets now. A is equal to 1, 2, 3 here. Same sets. Every element set A, every element of set A, 1 is here also 1 present. 2, here also 2 present. 3, here also 3 present. You can take set B also. You can take some more limits also. 3, 4, 5. Here also one more set is 3 is the second set also becomes 3, 4, 5. That is every set is subset by itself. ನಿಮಗೆ ಪ್ರತಿಯೊಂದು ಸೆಟ್ ಮತ್ತೆ ಅದೇ ಸೆಟ್ಗೆ ಸಬ್ಸೆಟ್ ಆಗುತ್ತಾ ಇಲ್ವಾ ಅಂತ ಚೆಕ್ ಮಾಡಬೇಕಂದ್ರೆ ಒಂದು ಸೆಟ್ ಆಫ್ ಎಲಿಮೆಂಟ್ಸ್ ತಗೊಳ್ರಿ. ಎ ಇಸ್ 1, 2, 3. ಇಲ್ಲಿ ಕೂಡ ಎರಡನೇ ಸೆಟ್ ಕೂಡ ನಮ್ಮ ಸೇಮ್ ಎಲಿಮೆಂಟ್ ಅಲ್ವಾ, ಅದೇ ಎಲಿಮೆಂಟ್ ತಗೊಂತೀವಲ್ವಾ, ಅವೇ ಸೆಟ್ ತಗೊಂತೀವಲ್ವಾ 1, 2, 3. ಅವಾಗ ಚೆಕ್ ಮಾಡಿದ್ರೆ ಫಸ್ಟ್ ಸೆಟ್ ಅಲ್ಲಿ ಇರುವಂತ ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟ್ ಸೆಕೆಂಡ್ ಸೆಟ್ ಅಲ್ಲಿ ಬರುತ್ತೆ. ಅದ್ರ ಸಲುವಾಗಿ ಅವಾಗ ಫಸ್ಟ್ ಸೆಟ್ ಬಿಕಮ್ಸ್ ಸಬ್ಸೆಟ್ ಟು ಸೆಕೆಂಡ್ ಸೆಟ್. ನೀವು ರಿವರ್ಸ್ ಬರ್ರಿ, ಇಲ್ಲಿರುವಂತ ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟ್ಸ್ ಮತ್ತಿಲ್ಲಿದ್ದಾವೆ. That's why every set is subset by itself. That is in case of equal sets. Definitely in case of equal sets. So for example, you can take A and B are equal sets. A is subset B and B is subset B. In that case, we can tell that about this. That's why every set is subset to itself. That is represented by A is subset or equal to A. That is A is contained in A only. ಪ್ರತಿಯೊಂದು ಸೆಟ್ ಮತ್ತು ಅದೇ ಸೆಟ್ಗೆ ಸಬ್ಸೆಟ್ ಆಗುತ್ತೆ. ಯು ಕ್ಯಾನ್ ಟೇಕ್ ಎನಿ ಸೆಟ್ಸ್, ಬಿ ಸೆಟ್, ಸಿ ಸೆಟ್ ಆರ್ ಡಿ ಸೆಟ್, ಬಟ್ ಇನ್ ದಟ್ ಕೇಸ್ ಎವ್ರಿ ಸೆಟ್ ಈಸ್ ಸಬ್ಸೆಟ್ ಬೈ ಇಟ್ ಸೆಲ್ಫ್. ಇಟ್ ಇಸ್ ದ ಫಸ್ಟ್ ಪಾಯಿಂಟ್. ಸೆಕೆಂಡ್ ಪಾಯಿಂಟ್, empty sets is null set to every sets. Empty sets is subset to every set. Is subset to every set. You can take some for sets. You can take some set of all subsets to one set A. In that set, null set will come. That's why we can tell null set or empty set, it is subset to every sets. You can take A, B, C, D. You can take any number of sets. At the time, you can write a number of subsets to given set. At the time, among all those subsets, null set is one subset. ನೀವು ಎಷ್ಟು ಸೆಟ್ಸ್ ತಗೊಳ್ರಿ, ಆ ಸೆಟ್ಗೆ ನೀವು ನಂಬರ್ ಆಫ್ ಸಬ್ಸೆಟ್ಸ್ ಬರ್ತಾ ಇದ್ರೆ ಡೆಫಿನೆಟ್ಲಿ ನಲ್ ಸೆಟ್ ಬರುತ್ತೆ. ನಲ್ ಸೆಟ್ ಪ್ರತಿಯೊಂದು ಸೆಟ್ಗೆ ನಿಮ್ಮ ಇಷ್ಟವಾದಂಥ ಯಾವ ಸೆಟ್ ತಗೊಳ್ರಿ, ಆ ಸೆಟ್ಗೆ ನಲ್ ಸೆಟ್ ಅನ್ನೋದು ಯಾವಾಗಲೂ ಸಬ್ಸೆಟ್ ಆಗಿರುತ್ತೆ. ದಟ್ಸ್ ವಾಟ್ ವಿ ಕ್ಯಾನ್ ಟೆಲ್ null set or empty set. We can call it as null set also, no problem. Just I have with empty set only. Even when I told definition of empty set, at the time I have given one more name to this, null set also. Null set or empty set both are giving a same meaning. That's why we can tell here empty set is a subset to every sets. This is the second point. Now some more points under note here. Another note on importantly here, one more point, third is, let A comma B comma, let A comma B and C are the three sets, are the three sets, are the three sets such that if A is subset C, A is subset B, and B is subset C, B is subset C, then definitely A is subset C. A is a subset C. If A is subset B and B is subset of C, then definitely A is on subset C, or written like this also, no problem. You are getting any confusion means just if you write like this, and afterwards if you write C in capital letter like this. A is subset C. A B subset आते, B C subset आते, then definitely A is also subset of C. See one example. Example for this is A is equal to 1 comma 2 elements, B is equal to 1, 2, 3, 4 some elements, and C is equal to here 1, 2, 3, 4, 5, 6 some elements. We check first condition check. A is subset B or not? Because every element of A is the element of set B. That's why we can write A is subset B. And definitely set B is the subset of C also. B is subset to C here. Because every element of set B is the element of set C. Then if you can compare set A to set C, if you can observe set A to set C, every element of set A is the element of C. That's what we can write A is subset of C also here. Now first ಕೇಸಲ್ಲಿ subset B ಚೆಕ್ ಮಾಡ್ಕೋಬೇಕಂದ್ರೆ set A ಇರುವಂತ ಎಲಿಮೆಂಟ್ set B ಅಲ್ಲಿ ಇದೆಯಾ ಇಲ್ವಾ? 1 ಇದೆ, ಆಮೇಲೆ 2 ಇದೆ. That's why we can write A subset B. ಆಮೇಲೆ ಸೆಕೆಂಡ್ ಸೆಟ್ B to C ಚೆಕ್ ಮಾಡಿ. ಸೆಟ್ B ಅಲ್ಲಿರುವಂತ ಎಲಿಮೆಂಟ್ಸ್ ಸೆಟ್ C ಅಲ್ಲಿ ಇದಾವ ಇಲ್ವಾ? ಚೆಕ್ ಮಾಡಿ. 1 ಇದೆ, 2 ಇದೆ, 3 ಇದೆ and 4. Next last finally check them A and C two sets. Set A ಇರುವಂತ ಪ್ರಸನ್ನ ಎಲಿಮೆಂಟ್ set C ಇರಬೇಕು. ಇಲ್ಲಿ ನೋಡಿ. Set A ಅಲ್ಲಿ 1 and 2 ಇದಾವ. These two elements are present or not in set C. That's why we can tell A is subset of C also. That's why this is the important condition in some competitive level examinations also we are using like all these conditions. That's what I am telling about all these main important points under the note of subsets here. A is subset of B, B is subset of C, and definitely A is the subset of C. Next, fourth. If A and B are two equal sets, if A and B are two equal sets, A and B are two equal sets, then A is subset or equal to B, or we can write B is subset or equal to A. Equal means they are equal sets here. Subset or equal. B to A. B is the subset and at the same time equal. That means if A and B are equal sets, then A is subset of B and B is also subset of A. B is also subset of A. It is the very important condition. Example that I'll give you one example in case of equal sets. How they are becoming a subset to each other. I'll show you by examples here. Example, 4-point example. A is equal to here 1, 2, 3, 4 here. B is equal to here, you can write 4, 3, 2, 1 here. First, these two are equal sets or not. Order is not important. In case of equal sets, I told an example. If every element of set A is the element of set B and reverse, and every element of set B is the element of set A, then we are calling those two sets are equal sets, and symbolically it is represented by A is equal to B here. That is the definition of equal sets, and we discussed and I told about definition also in that class. Now we are discussing about subsets. In case of equal sets, we are telling A is subset of B and B is subset of A. And what we got from LHS, same time, same result will get from RHS to LHS also. Let us now, we are going to checking now. A is equal to B. A is subset to B or not? See here, every element of set A is the element of set B. 1 is there, 2 is there, 3 is there, 4 is there. Or equal, why we are writing equal means they are equal sets. They are equal sets. Number of elements same and they have same elements. Number of elements same and they have same elements means we are calling those two sets are equal sets. And move reversely first. B is subset of A or not? B is subset of A because 4 and 4 is there. 3 is there. 2 is there. 1 also is there. That's what we can tell B is subset or equal to A. That's why in case of equal sets, A is subset or equal to B or B is subset or equal to A. That's why today I have given 4 points under the important points under the note of subsets here. Next we will discuss some other important definitions here. Intervals as subsets of real numbers. Intervals as subsets of capital R. R means here set of all real numbers where R is equal to here set of all real numbers. Set of all real numbers. Here, in case of intervals as subsets of R means, we'll see different types of intervals here. Close interval, open interval, half close or half open. Like that here, we'll see different types of intervals. First, close interval, how we are representing with close intervals here. Close interval. Closed interval here. Take one letter. Here, one real number lying here. On that real number, I have taken two real numbers A and B here. It is A and it is B here. The interval should contain A and B and between them. The interval contains some subsets of real numbers. Some subsets of real numbers. Those real numbers must and should present with A and B and between them. Here, with A and B and just we are filling A and B also here. ಈ ಕ್ಲೋಸ್ ಇಂಟರ್ವಲ್ ಮೀನಿಂಗ್ ಏನಂತಂದ್ರೆ ಒಂದು ರಿಯಲ್ ನಂಬರ್ ಲೈನ್ ಮೇಲೆ ಎರಡು ರಿಯಲ್ ನಂಬರ್ಸ್ ತಗೊಳ್ಬೇಕು A and B. ಇಲ್ಲಿ ಕೆಲವು ಸಬ್ಸೆಟ್ಸ್ ಫಾರ್ಮ್ ಮಾಡಬೇಕು. ಕೆಲವು ಸಬ್ಸೆಟ್ಸ್ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ 10, ಇಲ್ಲಿ some 20. 10 to 20 how many real numbers you get? Infinite numbers. ಆ ಇನ್ಫೈನೈಟ್ ನಂಬರ್ಸ್ ಸಮ್ ಸಬ್ಸೆಟ್ಸ್ ಫಾರ್ಮ್ ಮಾಡಬೇಕು. ಆ ಸಬ್ಸೆಟ್ಸ್ ಫಾರ್ಮ್ ಮಾಡಬೇಕಾದ್ರೆ ಕೆಲವು ರಿಯಲ್ ನಂಬರ್ಸ್ ಬೇಕಲ್ವಾ? ಆ ರಿಯಲ್ ನಂಬರ್ಸ್ ಹೆಂಗೆ ತಗೋಬೇಕಂದ್ರೆ ಕ್ಲೋಸ್ ಇಂಟರ್ವಲ್ ಮೀನ್ಸ್ a and b, including a and b, including a and b and between them. Then we are going to form in subsets with the help of those numbers. That interval is called close interval. That is definition for this, and it is represented by like this close interval, like this close a comma b, close interval. Close means including a and b and between them those numbers. Including a and b, between them those numbers. Example also I told. For example, you can take 10 and second number some 15 also you can take. 10 to 15, how many number of real numbers are there? So many numbers, so many infinite number of real numbers are there. With the help of those real numbers, we are going to forming some subsets. Those subsets are called intervals as subsets of real numbers between including a and b. Including a and b means close interval. That is I am writing here. The interval containing a and b, containing the real numbers, containing the real numbers, containing the real numbers a and b and comma and between a and b, between a and b, between a and b is called close interval. Close interval. Close interval, and it is denoted by close in square brackets and b close square bracket like this, including a and b and between them those numbers, including a and b, including a and including b. That's why containing the real numbers a and b, containing the real numbers a and b means its meaning is including a and b and between a and b. Then with the help of those numbers we are forming some subsets to set up all real numbers. At those subsets defined in that interval, which interval? Close interval. Close interval means containing a and b between them. Then that is called close interval. And for that set builder form, how we are writing here? Here I am writing here. This set builder form of the set builder form of closed interval, that is closed interval a and b, is given by closed interval a comma b is equal to set of the elements x is such that a is less than or equal to x is less than or equal to b here, comma x belongs to capital R here. A is less than or equal to x is less than or equal to b, comma x belongs to capital R. What about capital R here? Set of all real numbers. This type of interval is called a closed interval. Closed interval means containing a and b containing numbers A and B. Between those numbers which are there, we must count them also. We must consider them also. With the help of those numbers, we are forming some subsets. Those subsets are intervals as subsets of capital R. That is the set of all real numbers. Next one is open interval. Next one is half close or half open. Half close or half open. About all this, next class we discuss. Today I have given subsets. What is subsets? And some important points also I told under the note of subsets. And afterwards I have given interval subsets of as intervals subsets as on set of all real numbers also. And that real numbers I have given some close interval, next afterwards open interval, next half close, next half open. Like that we'll discuss about all these important points of all those intervals, and after completion of those I'll give you definitions of universal set and power set also. After completion of those I am going to solving the problems from exercise 1.1. Thank you very much.